Hello boys and girls, this is Mr. So. Welcome back for another lesson of biology. Today we are going through lesson 43 of chapter 15, the discovery of auxin. Before you start watching the video, remember to like and subscribe my channel and also share the video to your classmates. Let's start. For the substance which controls the phototropic response in the plants, it is called the auxin. Why would auxin be discovered? This is because in the old times, a scientist called Charles Darwin, he grows the coleoptile, these small plants, at home. And he found that these coleoptiles, these small plants, they tend to move towards the sun when they grow and follow the direction of the sun throughout the day. That is how he started to give the study of phototropism in the plants. But of course, besides Charles Darwin, who is the first scientist to study phototropism, there are other scientists throughout the history also built up more knowledge about the plant hormone called auxin. Let's take a look at what they have done. The first experiment was done by Charles Darwin in the year 1880s. Charles Darwin, he investigated a region of the coleoptile which is sensitive to the unilateral light. Darwin, he carried out the experiment in 4 different settings. In setting A, it is a healthy, normal growing coleoptile. In setting B, it is a coleoptile without the tip. That means a decapitated coleoptile, 斬手嘅. In setup C, the tip of the coleoptile is covered by a light-proof cover. And for D, the body is covered. Under the action of unilateral light, after several weeks, coleoptile A, it bends to the left. No growth for coleoptile B, while for coleoptile C, it grows vertically upward. For D, it grows towards the unilateral light to the left. When Darwin compared setup A and B, he found that with the tip, there is growth. In setup B, without the tip, there is no growth. So we can conclude that the tip is actually needed for growth. Let's take a look at the result of setup A and C. Darwin, he would like to know if the tip is sensitive to the unilateral light. For setup A, when it is exposed to the unilateral light, that means receiving the unilateral light, it shows bend and growth. While for setup C, it has the tip being covered. That means not receiving the unilateral light. It does not show any bending or growth. The conclusion is the tip is necessary and sensitive to the unilateral light. Darwin also compared setup A and D as well. The question is the lower part sensitive to the unilateral light? After the experiment, setup D, even though the lower part is covered, it gives the same response as A. So the conclusion is the lower part is not sensitive to the unilateral light. So after the experiment, Charles Darwin, he gave 2 conclusions. That is, number 1, the tube is needed for growth, and number 2, the tube is sensitive to the unilateral light. And of course, the lower part is not sensitive at all. Please go to your textbook page 39 to finish the MCQ question 1 and question 2. A second experiment was done by Boysen-Jensen in the year 1913. Boysen-Jensen, he investigated the nature of signal from the tube of the coleoptile. That means, is the growth signal a type of chemical signal or not? He would like to know. Boysen-Jensen, he prepared 3 different setups. In setup A, the tip of the coleoptile is removed, and then an agar, 大菜糕啫喱, is put on top of the coleoptile. For setup B, an agar is inserted in the coleoptile, while for setup C, there is a mica plate, 1 sac pin, inserted into the coleoptile, under the action of unilateral light after several days. Only setup B shows growth and bending. If we just take a look at setup A and setup B, we can see that if there's agar only, there's no growth. However, if you have the tube and agar together, it shows growth. So the growth is due to the tube. This conclusion is the same as Darwin. And given that at that time, scientists already know that agar, it contains some molecular space inside. So if you add a drop of ink or maybe a drop of chemical with colors, the chemical they can diffuse through the agar. Down to the bottom. By comparing setup B and setup C, Boyce and Jensen, he would like to know if the signal is a chemical signal or not, since in setup B, the agar allowed diffusions to occur. So if it is a chemical signal, the chemical signal should be able to diffuse down. But in setup C, even though the tube gives the signal, it cannot diffuse down because the mica plate, one sec pin, does not allow anything to pass through. So since after the experiment, after a few days, only chemicals can diffuse through the agar to cause growth, and B still have the growth, so if it grows, that means the signal must be a chemical signal. Boyce and Jensen, he also did an experiment number 3 in the year 1913. He would like to investigate the side which the chemical diffuse down. Does it diffuse down to the bright side or to the shaded side of the coleoptile? Boyce and Jensen, he made the setup as follows. Setup A, he put a mica plate on the bright side of the coleoptile, while in setup B, he put a mica plate in the shaded side of the coleoptile. So use your common sense. You should know that for the chemical, they should be able to diffuse down the side without any insertion of mica plate. So this is how the chemicals should diffuse down. They should diffuse down the side without the mica plate. Under the action of the unilateral light, what happens a few days later? That is, only setup A has the bending and growth, while for setup B, no growth. Why? By comparing setup A and setup B, the conclusion made by Boyce and Jensen is, with light, the chemical from the tip can pass down the shaded side only. While it cannot be passed down in the bright side. Therefore, the chemical from the coleoptile tip can lead to growth, or what we call elongation of the cells. In the shaded side, where you can find the auxins passing down, you can see elongation of the cell. However, on the bright side, when there is no chemical, it does not show any elongation of cells. Now the question is, where are the chemicals on the bright side? Where did they go? So far, the scientists have no idea about that. The fourth experiment was done by scientist called Paul in the year 1919. He investigated the effect of chemical concentration on the growth of coleoptile. He cut out the tube of the plant and moved it to the side for setup A and B, and then put it into darkness. After several days, this is the result. Setup A, it grows to the right, while setup B, it grows to the left. The conclusion made by Powell is the side with a higher chemical concentration is going to have more growth, which leads to bending. The fifth experiment was done by scientist Wendt in the year 1926. He would like to know, when affected by light, how is the chemical concentration different in each side of the plant? Wendt, he did the following. In the darkness, the tip is removed and put onto the agar block for some time, so that the chemicals on the tip is going to diffuse down into the agar block. The agar block which received it, the chemicals from the tip is now put back into the coleoptile. After several days, the plants grow vertically upward without any bending. The conclusion made by Wendt is, when it is in the dark, there is no light, there is same chemical concentration on each side of the coleoptile. So there is an even distribution of chemical in the agar. Therefore, when the chemical goes down and diffuse down into the coleoptile, it is going to cause both left and right of the coleoptile to grow with same rate. So therefore, at the end, the coleoptile grows straight upward. For the next part, Wendt decided to put the setup under unilateral light. Wendt he did another experiment by putting a mica plate in the middle of the agar block and separated it into left and right, part X and part Y. After that, he put the tip right on top of the agar plate. Under the action of unilateral light, we should know that on the shaded side, there should be more chemicals, while on the bright side, there should be less chemicals. Using such idea, when the chemicals start to diffuse down, on side Y, the agar should also contain small chemicals, while on side X, the agar should have less chemicals. Now the agar with different concentration of chemical is put back onto the coleoptile, and after a few days, the coleoptile bends to the left. This is because on the right hand side it has higher chemical concentration, so it has more growth than the left hand side, so the coleoptile bends to the left. After the experiment, Wendt made the following conclusion, that light causes an uneven distribution of chemical. The shaded side, it receives a higher concentration of chemical, so it grows more than the other side. Therefore, the coleoptile bends towards the light. Because of the hard work of different scientists and the experiment they have done on phototropism, the conclusion we have so far are: the tip is needed for growth. Only the tip is sensitive to the unilateral light. The signal from the tip is chemical in nature. The side with a higher chemical concentration will show greater growth. The illuminated side or the bright side, they have less chemical, while for the shaded side, it has more chemical. Therefore, you can see an uneven distribution of chemical when there is unilateral light. Throughout the history, there are different scientists. They have done different experiments to investigate the chemical which is released from the tip of the plant. The following table shows you the nature of science. 科學嘅本質 Science is based on evidence. Science knowledge is also tentative 暫時性 and also dynamic 可變嘅。So for the nature of science, please read it on your own. This can be very helpful for you to do your worksheets. At the end of this lesson, there are still some questions unsolved, such as question 1. What is that chemical signal? We keep calling that chemical, but does it have a name? What is the actual structure of that chemical? We have no idea. Second question. What happens to the chemical on the bright side? Do they just destroyed by the light? Do they move away to the other side, the shaded side? Do they just disappear for no reason? We are not very sure. That is the end for the first part about the discovery of auxin. For the unsolved questions, I'm going to go through with you in the part 2. See you in the next video. Bye bye.